one to sing, is the choir. The pastor is the one to give announcement. The pastor is the one to, to preach. And what we have is every system you have to break them into blocks, and those blocks will be handled by individual units. So, like the task I gave to you now, let's say I ask you to write a program that accepts input, let's say accept scores from the user, accept scores from the user, add the scores, find the average, and then print the result. Then by the look of the problem statement, then you see that number one, we should accept input, right? We should find the average, find the average, find the average, right? And we should have another function to what? Print what? Print out what? The average. Print average. Okay. So we've been able to break down the entire problem or the entire task into what? Into actionable steps, actionable modules, and which we will call functions, right? So we will create a function to accept input, to find the average, and to print what? The average. We can actually write all this entire code, inside the main function. But in real life, in production, it does not make sense. You have to create all these tasks into units. Are we on the same page? Okay, so again, before I move on into writing the code whatsoever, what I want to also do is, how do we write functions? How do we now write functions? Okay, so there are three things which we have to do before we can write a function. Number one, we have to define what we call function prototype. Function prototype. Function what? The function prototype. You have to define the function prototype. You have to define, you need to now call the function, which is the function call statement, statement, and we have what we call the function header line. The function header line, please always write header line. This is header line, the function header line. So these three things must be stated for you to be able to use function. You must have what we call the function prototype. We have the function header line and body, and then the function call statement. All right. So that's just the three statements you must make before you can, you can use a function. But now, the major thing is, how do we write function? How do we write function? Are we on the same page? Okay. For a function, we must have what we call the return type. For a function, we must have what we call the return type, or we call it return data type. Return type, return underscore type, return underscore type. You must give the function a name. You must give the function a name. So let's say the function is find average. You can just write the function is find average. That's the name of the function. Because if you have to use the function, you must call the function by name. Now, the function must have a name, and every function may or may not have what we call parameter. Parameter. So for you to write a function, there's what we call parameter. So those parameters are placed in brackets. You pass the parameters here. You pass the parameters here. Then the function have what we call curly braces. In the curly braces, that's where you define the body, what the function actually does. So for every function, there's always what you pass to the function called what? Inputs. The body of the function will process the inputs. Then if the function will return something, will return anything back to the world, back to you, then we will use what we call a return statement, and that would determine what we call the return type. Okay, so let's try to start. Let's try to start. Okay, so let's say I want to print to the world. I want to create a function that will just be printing I love C++ to the world. So how can I write functions like that? Now, you will ask yourself, will this function accept any input? What will this function do? And am I going to return anything from this function? You understand? What am I passing to this function? What would the function perform on the input that I pass to it? And what will be the return type? Like engineering, in engineering, we'll always have, when we have a process system, we always have what we call the input to a process. Input, you have the processing unit, you have what we call the processing unit, the input unit, the processing unit. The processing unit will deal with the input, then to give you what we call an output. A simple example of an input unit of this system is maybe a blender which we use at home. You know, when you have a blender is a blending system. Let me use that word, right? So what do you do to the blender? The blender performs a particular task. It carries out a particular function, right? You pass in input to it. Your input can be onions, can be pepper, can be tomatoes, right? You pass this input to what? To the blender. So these are the onions, the garlic or tomatoes, whatever. They are what we call the input parameter, what we pass to the function. Now, how many parameter are we passing? Just like this now, in this diagram, we have just 3 parameter. Sometimes it could be just 1 parameter we are passing to the system. Sometimes we might not be passing any parameter to the function. Are we on the same page? Then when we pass in parameter to this blender, let's say we pass these 3 parameter, onion, tomatoes, and pepper. You understand? What does the blender do? The blender acts on this what? On this parameter. It acts on it, it processes it, it blends it. So we have a processing module in the blender. When it's done processing it, we have what we call our output. So you always have input, process, and output. Are we on the same page? Now, depending on the function, sometimes you might not pass anything to the function. Sometimes you might pass something to the function. So depending on what the function would do. All right, so let's try to write certain functions. Let me say I have a function, okay, it should be in small letter. I have a function that we are not passing anything to it and we are not returning anything. So let's just say we have a function that just say write hello, write hello to the world, to the screen, write hello, right? So how do you write a function? You specify the return type, Is this function going to return something? The function name, right? You specify the function name. Then in brackets, you can open the bracket, right? And specify what you will pass to it. Again, remember that, like I told you, for you to write a function, you must have what we call three things which you must specify. You must specify what we call the function prototype. This is the function prototype, telling us or giving us an idea what the function will do, or making us be informed of what the function will do and the name of the function. It's just like this. If I'm trying to send someone to you to get something from you, I would have pre-informed you that, oh, I'm sending someone. The name of the person is this. This is the complexion of this person. The person is collecting so 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 and so. So what I'm doing is I'm pre-informing the compiler that there will be a function, and the function is not returning anything. The name of the function is write hello, and there's nothing I'm passing to the function. So every statement you write must always have semicolon. And then those functions, you always define them outside of the main function. So this main is also a function. This is the name. For this main function, we are not passing anything. But for this main function, we are returning something. And what are we returning? 0. And what is 0? 0 is an integer. You understand? The name of the function, are there arguments to the function? Is the function returning anything? And you understand? So we want to write our own function. So this is what we call function prototype. So what's the second thing I told you if we have to define a function? I told you that we will have what we call the function what? The function header line and body. Okay, so the function header line and body contains what we call, displays what we call the full implementation of the function. With the function header line and body, you'll be able to see clearly what the function does. What are the parameters the function is accepting? If it's not accepting any parameter, what is it doing? So now this function we've we've talked about, we just know that the function, okay, its name is write hello, is we are not passing anything to it, right? And is not returning anything. But what does the function does? We don't know. So the prototype is just a blueprint. It's just to inform, right? But we need to now specify what the function does. So what do? We write what? Um, the data return type followed by what? The name of the function. Then we open the brackets. Then the curly braces. In this curly braces here, this is where we will write the body of the function. So let's say this function we just print to the screen. I love C++, even though some of you might not love C. Okay, I love C. I love C. Even some of you might. And hey, you understand? Let's just say I love C again. Maybe I love my lecturer. Okay, so this is what the function is doing. Now, from the body of this, the body of the function, everything inside the brace, inside the curly brace, right? That's the body of the function. So the body of the function tells us what the function is doing, right? So for this function, what is the function doing? It's just going to print I love C, come to a new line, it comes to the new line, and also print I love my lecture. That's the function. That's what it. So the function is not returning anything. We'll we would see cases where the function returns something. Okay, so that is the function header line. This is the header line. This is the header line, and this is the function body. This is the header line, and this is the function what body. So let me come here and comment. This is the function header line, right? And inside the curly brace is what we have what we call the function body. Now we've created function, wonderful, but the function is not in use. Look at it. The function is not in use. Look at it. Let's run it, whether we would have any error. I bet you we won't have. It will just be blank. Okay. You can see it's blank. Okay. So it's just like this. See yourself as a function. See yourself as someone that carries out a function. Now, you are there as an entity, right? You will be idle until someone calls you. Someone calls you, like if there's someone here called Shayo, it is until I call your name that you are summoned. See yourself as a genie, or you see yourself as, let me just say, genie. And the genie, when you watch films like Aladdin and the Lamp, it is when you summon the genie will ask you, ask me whatever you want, whatsoever. Right? So it is until I call the genie that the genie will work. So right now, the function will not run because I've not called it. So looking at this code now, we have two functions already. We have what we call our own user-defined function called write hello, and we also have what we call the main function. Why do we have the main function? The main function, when we have several functions, right? For the compiler to start running our program, it must start from a particular place. It must start from a particular function. And the first function the compiler looks for is what we call the main function. Do you understand? If, let's say, the president comes to Unilag, where do you think the president will first of all go to? Anyone? Where do you think, if the president comes to Unilag, where do you think the president will go to?
The VC's office.
Where?
Senate.
Good, Senate.
Oh,
Will go to the VC's office, right? Do you understand? Every other person, we are all functions, we are all working, we are all doing things. But the first person the compiler goes to access is the main function, and that's why we call it main. Then it also means that no two functions must bear the same name called main. You cannot create your function and call it main. No. So what the compiler will first of all look at is for the main function. So in this main function now, that's when we can now call our other function. So how do we call a function? How do I call you to work? I'll call your name, right? So for you to call this function, what you just need to do is to write the function, and that's all. So when I call this function, write hello, I'm calling you, write hello. You understand? What the write hello will do is it will come to implement this. It will say, yes, I am, and this is what I do. That's all. That's all. So when you call it, it will come to execute the body of the code. Now, let's run and see what happens in our program. Let's see. Voila! I love C. I love my what? I love what? My lecturer. Is that not wonderful? Now you can call a function as much as you want. So if I still want to print, I love C, I love my lecturer, I can still call. So you can call a function multiple times. One thing about function is you write it once, you use it multiple times. Write once, use it multiple times. So I can come here, say write hello, write hello. I can call it again. So what do you think will happen if I run this code? Anyone?
You
What do you
printed
think?
three times.
What do you say?
It's going
I
to print.
love
I love
and I
my.
love my
I
lecturer
love C. I
three
love
times.
my lecturer. It's going to print them 3 times.
Three times. God bless you. That's what you can see. So we write it once, and you can see you can see how beautiful, how sleek, and how clean your main function is. Look at your main function. Very clean. Just three statements in your main function. But let's assume that without function, and I want to write print I love C, I love my lecturer 3 times, 6 times. What would happen is I have to print type this, come here, maybe 100 times. Do you understand? And if you look at the main function, it's not clean. Everything is modeled up, right? Without the function. If I've not written the function, you will see that yes, the main function, there will be a lot of code in the main function. And if I have to debug, it will be hard for me to debug. But if let's say for example, there's an error somewhere in the right hello, I know where um, I can. So let's say I have an error here in the right hello. I have an error. You understand? And every time I want to run, it's giving me an error. Then I know that yes, this function could not run because I'm calling the function, but it's not running. Then I know the section. I have to go to right hello, to call it. Okay. Ayobami.
All right, sir. So concerning that defining functions,
Yeah.
you said we don't put it in the main function, that int
No, no,
main
no.
there.
You
Define it
don't.
before it.
What do you say?
You said we define our functions before the int main. So I'm
Yes.
wondering why are we using our why are we doing our prototype after the int main? Is it something that can be explained before the
Ye-
int main too?
Okay.
Like when
Okay.
you
Okay.
define it. Now you wrote void hello, write hello
Yes.
before.
Yes.
So why are we putting the prototype after the int main instead of before it? Is that
No. Listen. The prototype is before the int main. I am just making the compiler aware that later um, I'm going to define a function or I'm going to call a function, right? It's prototype. It's just pre-informing. Now, and then what the function does, the full implementation is written after. We have two school of thought, and I want to show you this. We have two school of thought, right? When you're writing, we have a school of thought where you can define, you can define, you first of all define your prototype, right? Define your prototype, and later you can write your implementation. Okay, so hold on. If we don't have, if we don't have our this thing, um, our function declaration, you will see that yes, it's giving us an error because there's nothing for it to run. There's nothing for it to execute. We are calling this function, but there's nothing for it to execute, right? So we must define its what? We must define the full implementation of the code. So let me go back. We have two ways in writing functions. Two school of thought. One school of thought is we define our prototype to pre-inform the the um, the main function that yes, there's a write hello. You understand? So you can see if our code is running sequentially, you understand? It has already seen write hello. You understand? It has already seen write hello. Let me comment this out. It has already seen write hello. So it knows that there's something called write hello. Do you understand? Look at it. It's giving me an error. But I have the implementation here, right? So already the main function is aware that there's something called write hello. Yes. So by the time you call the write hello here, then the write hello comes here to execute that body of work. So the school of thought says you have to define the prototype. You understand? And this is the call statement. This is what we call the call statement. This is where you are calling uh, the function. This is the call statement. This is where you are calling it. So if you don't call the function will not get executed. And this is what we call the full implementation of the code. So the second school of thought says you can you can you can decide not to write the prototype, but you have to bring your code. You have to bring it. You have to bring it before the main function. You understand? So if you do it this way, your program will still run. You understand? You can see that after when we disable or we comment the function prototype and our write hello is here after the main function, it does not work. You understand? Because you cannot call someone that you don't know. You must be aware of the person before you can call it. You understand? So another way is when you bring the full implementation of the code before the main function, you can actually call it and it will work. So let's call it now, and you will see we would not have any issue. You understand? But the standard way for this class is we would have what we call a function prototype written before we call the function, right? Then after the main function, we have the function header line and function body. Okay, so is Zabu blessing? Yes, kindly unmute yourself.
Good morning, sir. Or good afternoon, sir.
Good afternoon.
Yes, I have a question.
Please fire.
Sir, in when doing this, is there a way like we can like make this function like we can use it as an inheritance when we are writing and like other functions, like maybe
Definitely,
in the okay.
definitely. The word inheritance is a wrong use of term, because later inheritance is always used when you are talking about the concept of OOP. But let's leave that. I
Okay,
understand
there's
what
no O P in C, right? Okay.
you understand, and there's no OOP
Yes,
in C.
sir.
You
All right,
understand?
sir.
But
Yeah.
I understand that what you're trying to say is, can a function which you've created call another function? I think that's
Yes,
what you are.
yes,
Yes,
sir. Yes, sir.
yes. I can give you an assignment and you give it to your friend to do. Your friend can hire it out and contract it out. But at the end of the day, the assignment will get done. And if I ask you return the assignment, it means it will be passed back through those lines, you
Yeah.
know, to get to me. Okay, so
Okay, sir.
let's try. Let's try. Let's try.
Yeah.
Let's
Thank you,
try.
sir.
Let's rewrite something. Um, what do you want me to write now? Okay, the same way, let's write another function and just say um, write I. You understand? Let's just call this write I. Void write. Again, when you are writing your function, you must be very sure that you are not misspelling the function. You understand? You're not spelling it wrong. Hmm? Look at this now. I call it write I there, but just imagine I use small letter H here and I try calling the function. You will see that it will not call the appropriate function because it's two different. It's two different things. So if I come here, say write I, um, you can see it's already. You would have issues. Or let me just use small letter. Let's say the function print. I'm just using print. There are other things I can actually do. I want to make it um say I love you a lot. So now there will be error because the prototype um the prototype is not matching. You can see there's error. You understand? So you have to be very sure that what you're writing, the name is just the name. C++ is sensitive. So now let's do this. Let's come here and call write I. So I'm trying to show you that I have a function. The main function, this is the main function, calls write hello. You understand? Write hello, write hello. And write hello is calling what? Look at it. This write hello is calling what? Write what? What's it calling?
Right eye.
Write I. So I can call you and you can call another person. So let's see. I love C. I love my lecturer. I love what? I love you, Lord. So, but in the main function, what are we calling? What are we calling in the main function? In the main
Right.
function, we are only
Right
calling
hello. Right
hello.
hello. Right hello.
But inside the right hello, right? Inside the right hello, um, the right hello is calling this. So look at it. So when the right hello starts executing, it first of all print this. It comes to it always runs sequentially one after the other. So then it comes here and call this function. So by the time we call this function, the function says, I love the Lord. So a function can call another function. So one, one, we've been able to see the concept of the function, how we can write a function, how we can call a function. And now, this function, this function that you see has no argument. You can see there's nothing we are passing to it, right? There's nothing we are passing to it. And this function is not returning anything. Okay. So let's say we are passing um I don't want to go too advanced. Let's just say I'm passing age. I'm passing something to this function. So in the prototype, what you would do is you will have to write the data type and the variable that will accept whatever you're passing to the function, right? I'm coming Sultan. Coming Sultan. Okay. So it must match. You can see now they are not matching, right? It must match. So I can just give it int age also, int age, right? So it means this function accepts how many parameters? How many?
One.
One parameter.
One. Thank you. You can see here, it's already giving me an error. It's giving me an error. What's the error? Too few
So
arguments.
arguments
So
in
that is
function
to say
of.
there's no argument here. There's nothing you are passing. You told me that this function accepts one argument. Why are you passing nothing? So let's just say I'm passing 10 now. You will see it will clear. Can you see? Are we on the same page? So
Yes, sir.
it's saying yes. Just like here in Unilag, before you came in, we said, oh, for you to come in, there's something we accept. We accept your O level result. You know, you have to bring everything. Just assume that you did not bring everything. You only brought jam and jam alone. That is not sufficient to give you admission. We told you we accept about 3 requirements, and you must bring those 3 requirements. You understand? So hold on, Sultan. Okay, Sultan, can you ask your question?
Okay. Good afternoon, sir.
Good afternoon.
So when in declaring these functions, so
Yes,
you
sir.
have said you have declared the one that does not return any value, which is this void.
Yeah. Yes.
What about if we are going to return a value? How are we going to how will
And
the format?
hold on, Sultan. Sultan, I've
Okay.
been lecturing, I've been teaching this for quite some years now, minimum of 9 years, right?
Mm,
So
mm.
you don't, you teaching is progressive. You understand? I want to teach you it does not accept. What if it accepts
Okay.
one? What if it accepts two? It accepts three. What if you want to return? You understand? So
Okay, sir.
it's good you asked the question, but just hold on. We are getting there. You
Okay,
understand?
sir.
So that's why I
Yes, sir.
started with not you are not passing anything and you are not returning anything. That's where I started from, right?
Yes, sir.
Again, I want you to know that for the first case, when there's nothing here, when there is nothing here, it can be blank or you can type void. Do you understand? It's acceptable. Are we on the same page? Is either it's blank or you type what? You type what? Void. So
Void.
if you call this, it will run. Oh, sorry. I think there's still something here. Yes, I'm calling right there, which does not exist anymore. I've deleted it. You understand? So it will still run. Can you see? Even though I put void. So void means nothing. Hmm? So um so it does not accept. It does not accept and it does not return. Okay, good. Let's just say it accepts just one argument. And remember, in the function header line and in the function prototype, two things. In this prototype, you can just put in the data type. You can just put in the data type. Remember, the prototype, you are not writing everything. You are just informing the compiler. So you don't need to, it's not necessary that you put in the variable name. Just the data type is enough to tell us that yes, there's one argument that will be. But when you come to the function header line and body that talks about the full implementation of the code, then you have to specify the data type followed by what? Followed by the variable name. Now, please, I want you to pay attention critically to me. It will really help you a lot. And what am I saying? This int age here, this int age belongs to this function. This int age belongs to what? This write hello function and is in this parameter. It means if I pass 10 here, if I pass 10 here, it's more like I'm passing 10. Look at it. Do you understand? In the main function, when I call this function and I pass 10, let's say because I said this function accepts integer what argument, right? So if I pass 10 to it, it means I am assigning 10 to whatever is the container. This is more like a placeholder. It's just like if you throw a ball to me, I have to catch it, right? So if you are passing 10, it is here. It's more like saying its age equals what? Equals what? 10. So because I have defined this age and it has accepted a value, then I can come here and say I am I am dash years old. Then I come here and specify what? Do you understand? I am so whatever your this age, the value which is 10 will be placed where? Yeah, I am 10 years old. So let's run and see if it works. Moment of truth. I am 10 years old. Can you see? Are we good?
Okay.
Yes, sir. Yes, sir.
I can change it once, write it once, maybe 25. It can be anything, 500, and write it. So here in the main function, that's when I'm calling the function. I am calling the function to what? I am 500 years old. Can you see? So if I don't call the function, I'm stressing this. If I don't call the function, will anything be printed to the screen?
No.
Will anything be printed to the screen? I want input from you guys.
No.
Okay.
No, sir. No, sir.
No. Why? You are just idle. The function is just idle, right? It's just idle. By the time you call them, you know, or let's see this function as more like they are contractors. They are contractors. And these contractors, for you to call them, you have to pass an argument. Maybe you have to pay them certain token. You must pay them before they work. You must, do you understand? So if you don't call those contractors, they will not work. They will not come. So imagine write hello as a function as a contractor, and they are there, and I just want to say I want to write hello. I'm calling them to write hello for me on the screen or to say I am dash years old. Then by the time you write them, you call them here, but you are not giving them more like fee, maybe agency fee or cash to be able to transact or to carry out the project. They will not work. You are just calling us for fun. So you are calling this right hello, but you are not passing the argument because it says for you to call me, you must pass an argument to me. Just one. So then by the time you say, and the argument must be what? An integer. You understand? So I must pass an integer to it and it will run. So it can be float. It can say, oh, it is float that I accept. It is not an integer, but it's float. So you have to change both the prototype and the, so it's float. By the time I'm calling it, then I can give it any value and oh, error. There will be an error. There will be an error. Look at it. I am minus 2, 1. Do you know why there's error? Anyone? Moment of truth. Why is there error?
The
You
format
use the wrong
specifier.
The
format
format
That format
specifier.
specifier.
specifier. Yeah.
Thank you. Thank you. Thank you. So you change it to the right format and we should see 55 points whatsoever. If that age exists, I don't know who is 55 point something yet, but you know, you understand the the stuff. Okay, so now, so you can see, so it accepts this right hello accepts just one argument. You can write it can you can create a function that accepts more than one argument. You can create another one. Let's say, oh, you are accepting two arguments. You understand? So if you are accepting two arguments, so here also let's say float h2. By the time I specify this, you can see I'm already having error in my function call statement. This is where I'm calling it, right? It's already giving error. And what's the error again? Too few arguments in what?
In function call.
You can see now that you are already getting used to debugging. So let's say someone runs and you are seeing, let me just run this, it will not work. And I say no. Look at it. Look at it in my output. Look at it. Number one error is truncation from double, but let's click that. The second error is too few argument for all. That is to say, the argument for this function is too few. You specify that it accepts two what? Two arguments. Now you are putting one. No, it does not work. But the moment I just um, specify any other value, it does not, and there's no more error on the screen. Okay, so then again, I just specified just one age. I can say I am 10, I am dash years old, but my father is dash years. So you can see I specify one format specifier, one should be year, that's age, and year should have another format specifier. So it means I have to put another argument, age 2. You understand? So I can call this function multiple times. That's the beautiful about functions. You can call the function multiple times and pass, let's say 22.0, and you're passing 6.7. So I just wrote the function once, but I can what? I can call it multiple times. You understand? So again, let's run. Let's see if it works. I am 55.1 years old, but my father is this. I am, but my father is this. Voila. Good. Good. So look at this. We've written a function that accepts two arguments. The same way for three arguments, right? You're just increasing the arguments. Yeah, you have to specify it explicitly. Let's say age 3. You understand? You can increase as much as you want, but they are not returning anything. They're not returning anything. For you to return, okay, let's write another function and call this function find average. Find average. Find average function. Let's call it find average function. So the function will help us find the average. And what is average? Sum divided by the frequency. So let's say we want to find the average age. Here, we want this function to find the average and return the average to us. So remember, if they are of floating point and you want to find the average, you will agree with me that the average will also be a floating point, right? Do you understand?
Yes, sir.
Float. So let's change this to what? Find average. Again, the name must match. You understand? You cannot make mistake maybe just changing the A to be small letter while it is capital letter here. There will be issues. So always be consistent with whatever you're doing. All right, find average. Um, let's come here. Let's say find average. Um, let's put it there. Let's say, let's say okay, now there's something I need to make you understand. So if we have to find the average, how do you find the average? You can find the average in this way. You can find the average in this way. You can say return um, age 1 plus age 2 plus age 3, right? All divided by 3. So average means you add them together, divide by 3, right? Look at it. For you now to return, maybe I pass something to you, you work with whatever I passed to you, maybe a token, you work with it, then you want to return a value. I can give you a cash, help me get this thing in the market. You visit the market, you got it. You know you have to return back to me, right? Whatever you got, right? So this function accepts whatever you pass to it. So it means that if this is the function call, we pass this first will go to the first argument, the second will go to the second argument, while the third one will go to the third argument. Are we on the same page? Then you find the average. After doing this computation, the result is now returned back saying, okay, this function, oh yeah, you return it back to the main function that calls it. Are we on the same page? Now, I want you to pay attention. I want you to pay attention. And this is the attention I want you to pay. Two things. If a function returns a value, if the function, one thing about function is they are just like contractors. When you call them to work on site, they will come, they will create their local variable, they will, bring the equipment on site, they quickly do whatever they want to do, and they will exit. When they exit, you won't see any trace that they were there initially. So when you call this function, what it will do is, you know, it will come here, pass the argument, it will set up these local staffs, this local variable, it set them up, it does this computation whatsoever, then it exits, it returns the value and disappear. When it disappears, the value being returned must be saved somewhere, must be captured. You understand? It's just like this. If I throw something at you, if I call you and I pass something to you and you return something back to me, I must be able to catch it to capture it. So if I have to capture it in the main function, then it must be held somewhere, in a variable, in a storage location. So it will be good for me to now create a variable, let's say float result. I can call it float result equals to this. Yes, it means, yes, come in. It means this function gets executed. Oh, hold on. Class, just give me a minute. Let me see who's at the top. So it means this function gets executed, find average gets called with the arguments. When it's done, it returns the value more like, let's say it returns 5. It means at this position, when it is done working, it returns 5. Everything becomes 5. And that 5 is saved in the result. I hope you understand the logic now. So then result holds whatever is returned from this function. Then I can come here and say print what? I can print the um, average value if is what? To put the then is a floating point. Let me just specify new line. The floating point, then the print output my result. You understand? So this function you can see is consistent. It's consistent. So let's find the average. So that's the average. So can you see? So it would add, let's add it. Let's look at calculator. Calculator. So let's say we have so let's say have 55.778 plus 102.4 plus 201. What's the answer? Sorry, let me see. That's the answer. Yes, divided by 3. 119. Can you see? 119.426. No. Are we on the same page? So um so that's that. But now you can do this, but is a very what it's not good, it's not a good programming practice to write this. Most of the time we always love to be explicit, right? Explicit. So to be explicit, we can come here and create we can come here and create a variable and just call it average, and we say average equals this. You can come here and say average equals this, and then we come here and say return what? What are we going to return? Return out. Come here.
Return average. Yeah.
Can you see? Do you understand? So every time if we have to return anything, we must use the return statement. So it means I call this function and passing the argument. So the argument comes here. 102 goes to H2, 200.1 goes to H3. When it computes, which is the body, and it returns, the value being returned is sent back to that same position. Who called it? Main function called find average. Find average now returns value. Then that value being returned is saved where? Into the result. Then we print out the result. Oyetade, please.
Good afternoon, sir.
Good afternoon.
Yeah, sir, please, what's the difference between when we print inside the function and when we return it before we print?
What do you say, please?
I said, what's the difference between printing inside the function? Like, can we not print the result inside the function?
We can now listen. I can decide to print my result here, the average here. Do you understand? I can decide. To print that. Sometimes, depending on the task being given to you, it might not require that you print inside this function. It might just require that you just find the average. You understand? Remember that whenever you are creating a function, your function must be able to just do one particular task. You understand? Printing out the results or the average is another task. You might create a separate function to print out the result for you. But this function task is to find the average. Then it has done finding the average. Then it returns the average. Then you can create another function to print the results. Are we on the same page? To print the results. Then you can come here and say, now if we are creating a function to print results, will the function be returning anything for us? You just want to print the result. Do you need the function to return anything?
No.
No.
No. Is that clear? No. You just want to print. You don't need to give feedback back to you. But now, if we say print result, do we need to pass anything to the function? Anyone? Must there be argument to that function?
Not
I hope you
necessarily.
can hear me. What do you say?
Not necessarily.
If I want you to print something for me, wouldn't it require that I give you something to print?
Yes, sir. Let's
What do you say?
find.
So it will require that I give you something to print. So I come here, print results. So this the name here is just a placeholder. You understand? It's just a placeholder. So I can call it results and call it anything. Anything. I can call it res. You understand? But you know the rule of creating variable, it must convey meaning. It must convey meaning. So I can come here and just do this. Let me just put this. Sorry. This. You can see I'm not using any return statement. So there's nothing, it's void, not returning anything. Okay. Um so here then for me to call print result, I'm now calling the print result. Then what am I going to pass here? Anyone? What am I going to pass?
Result.
Rest.
Results. Good. I'll pass the result. So this function helped me compute the average and it's stored here. Then I say print the result for me. So can you see the average value is this? So the first average, find average, will find the average. You understand? So you can see finding the average does not require for us to display anything to the screen. Does it? It does not because
No,
we're not
sir.
using any print statement. We're not using any printf statement. But it is in the print result that we have printf statement. Then that's the only thing that will show. Can you see? So you can now see how functions are handing over data. They are passing data. This guy computed the data. He stayed here. The data is now passed to this function, and that's how it works. That's how it works. So by the time I'm calling this function, the arguments are passed. The arguments are passed here. It computes, it's returned back to whoever is calling it. So, and so sometimes you always in C or in programming, the main function is the one calling this function. You understand? The main function is the one calling this function. Then the main function is the caller. We call the main function caller function or the caller. If I'm calling you, I am the caller, right? If you are what? You are the callee. 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 Right? I am the caller, you are the callee, or maybe you are the called. You are the called function. You are the called function. You understand? So if I'm calling Elijah, Elijah is the called. I am the caller, right? So I can decide, okay, I can decide that, uh, see, programming is just so simple that it just depends on what the task is. I might decide that it is not, my calling is not from the main function. You understand? It's not from the main function, maybe from the find average. So I can decide to say, okay, let me just delete this. Let me just delete this. I can come here and say, oh, uh, I'm not returning anything. Let me just, I can decide to tweak this and say I'm not returning anything. I would now call print result, depending on what you want, print result. And print result is a function. Then I can decide to pass in the average. And that's all. It still works. It still works. It still works. Works. You can see it still works, right? So what did I do here? Inside the find average, I find the average, then the result of the average is now passed to what? This function print result. But you can see that it is only the find average I will call. It is the find average that is now calling another what? Print result. Can you see? So print result can decide to call another function. Do you understand? Call, and they will just be calling themselves. Um, so with functions now, I've been able to show you that yes, a function must have a name. A function, in the function we have to specify if we're passing any argument or parameter. So we call whatever is in the bracket here, we call them argument of parameters or input parameter. Input, what are we passing to the function? So it's called input parameter or argument, or some author will say input argument, whatsoever, what you're passing to the function. Then you have to specify the prototype. These are the prototype. This is the full function, header, line, and body. And this is where you are now calling the function. If you are not calling the function, nothing will work. It is until you call the function and pass the necessary argument to it that it will work. Amusan,
Yes, sir.
kindly unmute yourself.
Yeah. So I want to ask if it is compulsory to always write function prototype or it's optional.
Well, for this course, I will want you to write it. The essence of me asking you to write it is sometimes you pick up um, certain textbook and you find it. If you are used to not having prototype, right, it might seem strange to you. So I want you to write it in this course, and that's it. But I've already showed you that if you don't want to write the function prototype, what do? you bring the function, header line and body before the main. So the main functions knows everything about the function before you call it. The main function must be aware of that function before it's being called. Do you understand? So if I come here and I comment all this function out, there will be problem because here I'm calling the functions. You cannot call a function without the compiler or the main function being aware of it. It's just like you cannot use a variable. Just like I told you about what we call, maybe I have not gone in depth, what we call scope of a variable. If here I'm calling the variable here, let me see this function as a variable. If I'm calling it here, it means I'm using it. I'm not, do you understand? I'm using it here. If I have to use it, it means I must have defined it somewhere before I can use it, right? So here now, I've already hinted or described it or declared it. I've declared it here. I declared the function here, but here I am defining it. In the definition, you are explicitly telling the compiler what that function does, what are the arguments, and all that. So sometimes you might see some authors, some books put declare variable, declare the variable in the prototype also. There's no sin. There's no sin with it. You understand? There's no sin if you do that. Understand? You can. There's no sin actually. It will still work, but you just have to be consistent. You just have to be okay. So, but basically, I always tell my students in the prototype, just um, just declare, put the data type in the main function. So I think that is just it. I wish I can just give you a classwork for you to do. But I just want to see if you will be able to show me. I need someone to show me. Okay. So sorry. Okay. So I think that's basically about function. Now, another thing you need to know is here in my argument, you can see they are just float, int. Your argument can be a character, um, can be string of an array, it can be anything. You understand? So what I'm trying to okay, let's 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 do something. Let's just let me just want to show you that it's not only float, you can print anything. So let's say I'm only printing a character. You understand? Come here, just a character, rest, and must specify. I think. So then you can come here and say print result, and what you're passing might just be a. This might just be what you're passing, just a character, right? And it's accepted here. You pass A, the A comes this. Come here and you print it. Then you say the character to print is this. So save it, run it. Let's see. The character to print is what? Is that. Okay. There are other things I can do, but I'm trying to limit them uh, of because I've not taught you. So learning is always progressive. It doesn't mean I can't teach you certain things, but um, it's just progressive. So today, basically, I've been able to teach you. I've been able to teach you character. You can do a whole lot of things. You can decide, okay, I want to print this character so number of times. Let's say so number of times. And it means if you know the number of times you want to print it, then you use the for loop or you use the while loop and all that. Okay, so I've been able to talk about the function, what the function does, what the function does. That every function you must give it a name, and this is the name of the function. But you must ask yourself, what am I passing to the function? What will the function be doing? Will it also be returning a value? You understand? I told you that for you to specify a function, you must specify the prototype, you must specify the call statement, and those where you're calling the statement, and you must also specify the function header line and body. So this is the header line, this is the body in brace. Okay, so that's the function, and I have been able to show you that function can accept nothing, no arguments. It can accept one, two, it can accept any number of arguments, you know, and it can also return. It can accept and it can return. Depending on the question, if I ask you find the average three score one, score two, find it, then return the average. It means the function will be accepting those three score, it will process it, and it will return the average. So depending on the nature of the question, that will determine how the function will be written. So I've been able to explain um, more like everything um, about functions. So I want you to take your textbook, read, and practice. All right. Because of time, um, let me teach you another concept, and the concept is what we call pointers. Pointers, pointers, or pointer. And what's the concept again? What's the topic again?
Pointer.
What's the topic again?
Pointers. Pointer.
Yes, pointers. And what is a pointer? A pointer is a variable. It's a variable that holds or stores the memory location of another variable. So a pointer is what? Is a variable that what? Holds or
Hold
stores
down store.
the memory address of another variable. That is to say, it's um, it's pointing to the variable, pointing to the variable. Again, I want it to sync. Please let it sync. A pointer is a variable that holds or store the memory address of another variable, or 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 it's a variable whose value is an address of another variable. Woo! Please let it sync. A pointer is a variable that holds or stores the memory location of another variable, or is a variable whose value is an address of another variable. Therefore, it means that a pointer is pointing to the variable. It also means that because it's pointing to that variable, it can write value to that location, or get value from the location. It can get value from that location or get. Now, you might ask, what's what's the real life implementation of a pointer, or how can I understand pointer the more? How can I understand pointer? Now, just imagine we do pointers every day, you know. Or but let me give you a basic scenario. You have a kid brother or sister or your cousin, nephew, whatsoever, and you decided to give, you know, that person a treat. You took your brother to the mall or supermarket to get something for your brother or your cousin whatsoever. And when, as babies, as you know, as younger ones, what do you think they will be doing? They will love to point at any good or product on the shelf. They will point, they say, "Uncle, auntie, give me this. I want to buy this. Give me." Do you understand? When they are stretching their hand, they are pointing to an address. They are pointing to a location. And so, because they are pointing, you can help them fetch whatever is on that shelf, or you can look at it after fetching it. You can say, "Oh, let us return this. This, I don't like it. Maybe it's too costly. I don't like the product, stuff like that." So you can get something from that location and you can return something to that location. So that is to say, you can do what we call hmm, what we call read and write. You can read from that location, you can write to that location. And as we go on, you will understand more about pointers. Pointers is a very important concept in programming, especially C or C++. Okay, without much ado, um, can we start coding? I wanted to baptize you guys with coding. You are the first, let me say, majorly first set of students I'm teaching C. This is my first time, not first time, but in the university system teaching C. And This is the first time mostly that I'm I'm coding straight up. I'm not using slide. I don't want to be telling you stories. No. I want to be showing you as as it is. Normal good day, I should give you slides. We talk, 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 talk. At the end of the day, we might not have an implementation. We might not show much, you know. But what I just want to do this time around is let me just be showing you codes. Let me just take you directly to programming and all that. Okay, so let's say you have a variable called int age. That's normal variable for you. Now you ask me, sir, how do we create a pointer? So how do you create a pointer? The same way you create normal variable, that's the same way, but with a caveat. So a pointer, if it's going to point to a variable, the pointer must also have the same data type as that variable. That is to say, the data type of that variable must match with that pointer. So if I want to create a pointer for age, then the pointer data type must also be int, right? Int, and let's say, let me call pointer to age, or I can say age PTR or PX. You understand? But that doesn't, this is just still a normal variable. What makes it a pointer is you have to put an asterisk. You understand? Spending an asterisk to it. You understand? So with this is a pointer. You've created a pointer this way. You've created a pointer this way. So this way, the pointer, this is normal variable. Normal variable. While this is a pointer. Look at it. It's just more like the same way you create variable, but with an asterisk. That's all. Now, with this now, I've created a pointer, just like a, but I've not mapped the pointer to be pointing to something. The pointer is not pointing at anything. So how can I make it to point at the variable? Then I'll have to say age pointer px. I just gave it that name. We have different convention for you to create um, pointer. Sometimes you see someone say PTR. PTR means pointer, or some people will, we say P, and they might, if the age, let's say the age, they can just, maybe that P can be in capital letter, So this means pointer to age, stuff like that. But I'm just using PX just to, but that PX itself, the best way is just to use age pointer or age underscore pointer, age underscore pointer. That's the best. That's the best way, so that you know it's a pointer. Okay, so age underscore pointer equals, what's the pointer pointing to? What's the pointer pointing to?
Memory location.
Memory
Of
Memory
another
location.
address of
Yes, memory location. So how do we get the memory location of this guy, this dude, age? To get the memory location of any variable, you use the ampersand. Ampersand. Hmm? So, so that's the memory location of any variable. You use the ampersand. Because the pointer also is a variable, the pointer also have an address, right? But the value of, you can see what we are assigning into the pointer. The value of that pointer is what? The address of what? Of age.
age.
We're on the same page. So let's print out, print f, The value of pointer, you know, is I think it's asterisk, asterisk p. I need to verify that. Blah 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 blah. H underscore p here. So, and because of memory, whenever we are looking at memory are always um, in hexadecimal. Memory are always in hexadecimal. Sometimes you see memory address like this: OOX, OF1, 32, whatsoever. They are always in an hexadecimal. And depending on the architecture can be 32-bit. So if it is 32-bit, and you know that for hexadecimal, each letter is 4 bits. So if the architecture of this computer is 32-bit, then it means what? We'll be having 8 letters. So this is 1, 2, 3, 4, 5, maybe with F, B, C, A, stuff like that. You understand? So let's see. Let's practicalize this. Um, so the value of the pointer is this. For pointers, yes, I think the format specifier is asterisk p. So let's try. This something funny. Uh, Let me just show you where format specifier of pointers. Pointer p. Okay, p. The format specifier is p. All right. So p for pointer. I think I forgot. Yeah, I was thinking after. Apologies. You can see the value of the pointer is, look at it. This is what? Address 006. So how many? 1, 2, 3, 4, 5, 6, 7, 8. 8. 8 times 4, that's 32. So this compiler is a 32-bit compiler. It's a 32-bit compiler. So you can see. So we can also print um, um, the address of age. Age is okay, let's try. Sorry, you have to pardon me. Um, let's go. No. That's not what I want to print. Sorry. That's not what I. So what I just showed you is the address of the pointer. I wanted to print the address of age itself. You will see it match the address of age. You know, this is the value. This value of the pointer. This is the address of age. So it will match. You can see. So let me do. Come to a new line after it prints this. Come to a new line so that I can see that it match. So you can see 0035F8. You can see the address, the pointer is also the address of the page. You understand? The pointer itself, because it's a variable, also has the address of pointer. The address of the pointer is this. So how do you, like I told you, ampersand means address. So address of age underscore is here. So let's run. So you can see the address differs from um the address differs from that of the age. You understand? Because the pointer itself is a variable, so it has its own address. But the value of the pointer is the address of what? Of age. Now, you would ask me that, sir, what's the significance of using pointers? Pointers has a lot of significance. Has a lot of significance. There are some levels you will get to in programming. If you don't know pointers, you can't get there. When you get to something like data structure, you are talking about linked lists. You are talking about trees. You are even talking about passing arguments. There's something I forgot to tell you when we are treating function. In function, please, in function, in function, the function can only return one thing. A function can only return what? How many things? Just one. You can only use one return statement. If I want my function to return more than one statement, then I will use pointers. You understand? I will use the concept of a pointer. So, pointers help us to circumvent so many things. So, if I'm pointing to an address, I can get the value from the address, irrespective of wherever the function is or the variable the pointer is. All right. So let's move forward. Let me assume age has a value called 50. Age has a value called 50. If I am pointing to, if I'm a pointer and I'm pointing to age, it means I can get access to what is stored in age. I can read from that location, or I can, if I have your account number, you know, what we are saying is memory address. In programming or in real life, all you need to know is someone's address. If I know your address, I can come there, I can send a delivery guy to come and deliver something on your birthday. I can give you a surprise, you know, package, all because I know your address. If I know your bank account, which is an address, I can send money there. If I own your home address or I know Putin's address, maybe I can send a bomb. I can send bomb to that coordinate to that address. You understand? So address is important. I can send I can send anything to that address. If you have a video, rather than you passing the video to me, to everyone, maybe the video is 50 megabytes whatsoever, sending it individually to everyone can be costly. What you do is you put it somewhere, then you send the address of that location to everybody. So everybody can watch using the address. So the address is very important. So if I have a pointer pointing to age, I can get what is inside age or I can override what is in age. So how do we do that? We can come here and say the value, the value of age, you can do it directly. Since I know age, I can say, okay, print for me the value of age, right? Okay. I can use pointers actually to the value of age using pointers is let me do this so that okay. So what I would do is I would dereference. There's something called dereferencing. I will use asterisk to dereference. So yeah, dereference. I will dereference. Now, if I'm pointing to an address, right? What that means is I am referencing. Here, age underscore PTR is referencing age. You understand? Now, for me to get value from there, I will be dereferencing. I'll be saying, get me the value in that address. What I'm doing is dereferencing. So let's run and see what we have. Look at it now. You can see our memory change. Every time you are running, your memory tends to change, right? So the value of age is this. But using pointers, I'm able to dereference. How do you dereference? You use your asterisk again to dereference. So dereferencing using the pointer, because I know your address, then I can get what is there. Are we on the same page? Are we on the same page? So,
Sir.
yes,
Yeah.
yes. Any question?
No, sir.
Okay. So now I can, because pointers is pointing to age, it can update age without, I can update age by just saying age plus 50, add 50 to the existing 50. But with pointers, I can do this. I can say where I'm pointing to, where this age is pointing to. You understand? The value there plus equals to 50. Or let me just say plus equals to 100. Then let me print out the value of that age now. So what do you think I'm doing here? I'm saying where this pointer is pointing to, get what's the value there? Do you understand? Then add 100 to it and assign it back. Then using this, I've been able to modify whatever is in age. Then I'm trying to print out what age is, the value of age. Okay. So you can see that the new value of age is what? What's the new value of age?
150.
150.
150.
So you can see I'm not adding directly using age. I'm not updating age directly. I'm using the pointers. So the concept of a pointer is very important. And in the next class, we will dive deep into pointers. We'll do pointers, arithmetic, we, we would revisit array. We will revisit array in the next class. And we'll see how we can use pointers. Okay, so I don't know if there's any question before we call it a day. It's already, we are 2 hours gone. Any question? Any question? Anyone?
Yeah, yes, sir, yes, sir.
Yeah, please fire on.
So in that function, when you are creating a function,
Yes.
in the argument, can you put like different data types in the argument at the same
Yes,
time?
now, why not? I showed you that it could be any data type. They are just placeholder, whatever you want. In my explanation, when I use the blender as an example, I said you can pass in onions. Onion is different from tomatoes, it's different from pepper, it's different. Do you understand? We have different shades. They are different data type that you are passing to a function, to a blending
At the same
machine.
time.
Yes, is
Okay,
yes.
sir.
You understand? You can
Yes,
pass
sir.
anything. You can pass any number of arguments. You understand?
Mm.
So
Yeah.
I showed you how to pass in character, right? Um,
Yes, sir.
so you can pass in anything. Is that taking
Yes, sir.
any other question? So whoever I hope this recording, this is what I am trying to do. I don't want to record so that I would encourage people to be coming to class. But with the way I'm saying, guys just come, register, and they will exit the class, right? Before we're having about 40 something and people are exiting. No problem. There's always a way to there are many ways to skin a cat, right? So I don't just want people to, to be relaxed. I want them to and give the best. Please, I want you to practice. I want you to read and practice. And you will see coding is life, it's fun. All what I've been teaching you now, there's no book beside me. I'm just teaching from my head. So that's what makes you a very good programmer. Internalize it, digest it, and you'll be able to write codes. All right. So I hope if this recording, if I should be able to get this recording and I will upload it. I will upload it. Okay. So take care, guys. Yeah.
Thank you, sir.
If we
Thank
also
you,
use
sir.
Thank you, sir.
yes, please. You can use YouTube tutorial. I'm not the only one teaching C whatsoever. Please feel free. Feel free. Knowledge is wide. That's why sometimes some lecturers do not tell you a reference material. There are materials out there. There are a lot of textbooks out there on C programming. So, so please feel free. Feel free. All right. It's great having you guys once again. I'm always happy teaching programming. So take care. We'll see you next week by God's grace.
Thank
Bye.
you, sir.
Thank you, sir.